Okay, it's 11:02, so I think we should get started. Good morning, everybody. I'd like to welcome you to our first Trainee Talks webinar for the fall session on dependency management and testing of AI-based software systems. My name is Lori Akiyama. I'm the program coordinator for Create SE for AI at Concordia University, and I'll be your moderator for the session this morning. And today we are pleased to present two of our Create trainees to kick off our monthly webinar series, Ahmed and Jasmine, who I will be introducing in just a few minutes. But before that, I would just like to go over a few housekeeping rules for our webinar today. If you could please keep yourselves on mute, which I believe everyone is, that would be great, just to eliminate any background noise. And when we get to the Q&A session, you can either use the chat function to ask your question, or you can raise your hand to ask the speaker directly, but don't forget to unmute yourself if you do that. And the session will be recorded today. We're recording right now, and it will be available to view later on our YouTube channel. So now I'm very pleased to introduce our two speakers. First, we have Ahmed Haj Yahmed, who is a master's student at École Polytechnique in software engineering under Professor Foutscom. Ahmed is originally from Tunisia. He has an undergraduate degree in software engineering, majoring in data science with honors. And his research currently is primarily focused on quality assurance of deep learning-based software systems, software engineering for ML AI, and dependable and trustworthy ML AI. And today he's going to be presenting his latest paper that was accepted for publication in the Empirical Software Engineering Journal on a deep neural network quantization assessment. And immediately following Ahmed's presentation, we're going to hear from Jasmine Latendresse. Jasmine is a PhD candidate here at Concordia University under Professor Ahmed Shihab. And Jasmine will be presenting her work on production dependencies, which she recently delivered at ACM in Michigan, the automated conference on software engineering. So we look forward to hearing from both of them. And without any further ado, then I will now turn the floor over to Ahmed for his presentation. Take it away, Ahmed.
Thank you. So I'll be sharing my screen. So do you see my screen?
Yes.
Perfect. Okay. Thank you, Lori. Good morning, everyone. So it's my pleasure to be here with you for this presentation. My name is Ahmed Haj Yahmed, and I'll be presenting today Diverget, a search-based software testing approach for DNA quantization assessment. This work was done in collaboration with Hussein Benbraik and Rania Zahtour, and under the supervision of Professor Foots and Professor Sonia Bouzidi. So first of all, I would like to start with my research interest and the presentation scope. So I am currently working on the reliability and the production readiness of self-learning system. So in other words, I am currently working on evaluating and improving the reliability of this type of system in production and in the deployment phase. So, and I am working mainly on two aspects: testing and repairing this system in the deployment phase and the production. So, and the scope of this presentation will be the testing of these system in deployment. So we'll have an example how to test the production readiness of these type, of one of the type of self-learning systems. So the presentation will be divided into 4 sections. We will start with the motivation, the proposed solution Diverget, the empirical evaluation, and we will finish with some conclusion. So currently, we are witnessing a constant movement of AI towards edge devices. According to Gartner, in 2022, 80% of smartphones have on-device AI capabilities compared to 10% in 2017. So on-device inference is the process of making prediction using a trained model that is running on the device. So this trend offers a lot of advantages, including lowering the inference latency by skipping the data upload to the server. It offers operation with little to no connectivity, and it reduces privacy issues. However, the computational cost of machine learning model and deep learning model especially prevent the direct application of on-device AI. So how the community and the scientific community is doing to enable this kind of inference. So quantization. Quantization is one of the most used compression technique to host practical sized DNN into edge devices. So quantization tries to reduce the memory that DNN require by reducing the precision value of weights and activation from a 32-byte format to a much more smaller format. So among the benefits of quantization, we have a faster computation, a lower memory usage, and a lower power consumption. And quantization came with slight degradation in the predictive performance. So quantization is nowadays widely used due to its simplicity, straightforward implementation, and applicability to a wide range of scenarios. And with this rising demand for quantization, the assessment of this kind of technique is essential. However, to our knowledge, no study has yet proposed dedicated technique to assess the real effect of quantization. Instead, traditional techniques that are used to evaluate practical sized and full size DNN are also used to evaluate the quantization effects. So this traditional technique tries to gather labeled data as much as possible and try to evaluate to what extent the predictive performance of a DNN is preserved after quantization. However, using traditional techniques results in small data sets that cannot properly represent the whole input space, nor reflect all the possible divergent behavior between the original model and its quantized version. So this leads to some scenarios when we can find the 2DNN version have almost the same level of performance on test data, but when they are deployed in real-world settings, we will see much more divergent behavior between these two DNN versions. So for that, we need an advanced quantization assessment technique to evaluate the real impact of quantization methods. So in this work, we try to propose Diverget. So Diverget is a search-based software testing framework dedicated to quantization assessment. Diverget's aim is to evaluate and assess the real impact of quantization methods by detecting difference-inducing inputs that result in behavioral disagreement between an original model and its quantized version. So here, difference-inducing inputs are any input that result in classification in different classification output between the original model and quantized model. So any inputs that the both models disagree on is considered as difference-inducing inputs. So how Diverget works? So first, we need to have an original model and its quantized version that we need to evaluate. So Diverget takes as an input the original test data and try to perform a transformation on these data, aiming to break some metamorphic correlation. And the Diverget process is iterative, using population-based meta-heuristic to improve the generation process, aiming to generate and to uncover all the divergent behavior between the two models. So the final objective of Diverget is to generate and uncover divergences and disagreement between the two models, to quantify the degree of disagreement, and thus to assess the quantization true impact. Okay, so in this slide, we'll try to cover how we design Diverget. So the design of Diverget is based on two main phases. So the first phase is the preparation phase, where we try to design our metamorphic relation, and we try to design our search space, and then we have the workflow. So as I mentioned, Diverget uses population-based meta-heuristics, and the workflow of any population-based meta-heuristic is as follows. We need to have a first population that was generated randomly. Then we have the fitness function assignment. So fitness function are functions that take a candidate solution as an input and try to see how fit or how close this candidate solution to our objective. And in our case, the objective is to induce divergence. So with these values, we try to perform some update operation to generate new population, and we expect the new population to be better in terms of our objective than their predecessor. These steps will be repeated until a stopping criteria is reached. So we'll try in the next slide to go through each of these steps in more detail. Okay. So first of all, Diverget uses metamorphic testing to automate the generation process of its different inducing inputs. So without going through much detail, we'll try to define what we mean by metamorphic relation. So roughly, metamorphic relations are logical relations that we design to, we try to formulate logical formulation, and the objective is like, we try to see if any kind or any situation, these logical formulation break, that means that we have a vulnerability, and we have a problem. So I will try to explain it very quick. So our formulation or our metamorphic relation says, like, if you have an original input X and the original model, if the original model predict correctly this input, then if we perform some kind of transformation, that a conservative transformation of this input, we should have like the model, the original model and the quantized model need to have the same predictive output. They need to agree on the output of this transformed input. Otherwise, will be if these relation breaks, we consider this input, this transformed input, as a difference-inducing input. So I will try to explain it more with an example to better understand what we mean by metamorphic relation. And for that, let's see how we worked in this paper. So in this paper, we conducted our study on the remote sensing domain using hyperspectral images. So hyperspectral images are images that are composed of hundreds of spectral bands, offering spectral and spatial information. So why we use this kind of image? Because first of all, they are rich in spatial and spectral information. They are highly vulnerable to distortion. They are rarely labeled, and they are widely used in on-device related application, which make them the best use case for quantization assessment. So to design metamorphic relation, we collaborate with domain expert from hyperspectral image to design naturally occurring distortions. And we group these distortions into two groups. First, we have radiometric distortions. Radiometric distortions are perturbation or transformation that affect pixel values of an image. Some example of radiometric distortion, you can find spectral band loss, line column striping, continuous line column dropout, region dropout, and salt and pepper noise. For example, geometric distortion, we can find like zoom in, zoom out, rotation. And if we take, for example, this example, let's say like we have an original image like this, and we have an original model. Let's say the original model predict correctly this image. Our relation says like, if we have a conservative rotation, the original model and the quantized model need to have the same output prediction for this rotated image, which logical. Otherwise, this image will be considered as the difference-inducing input, and it's considered as a problem. Okay, moving now to how we design our workflow. So, like I said, Diverget uses population-based meta-heuristic algorithms, and these algorithms rely on fitness function to guide the search toward optimal region. So the design of fitness function is really important in this algorithm. And for this work, we try to design two types of fitness function: a divergence-based fitness function and a coverage-based fitness function. So roughly, and without going through too much detail, the first type of fitness function is diversion-based fitness function, which just compute the Jensen-Shannon diversion between softmax output of the original and the quantized model. The second type is the coverage-based fitness function, which computes the Jacquard distance between the signature output, the signature activation nodal output of the original model and the quantized model triggered by an input X. It's a Jacquard distance between the internal activation of the two models. Okay, so so far enough technical stuff, and let's jump into the next section. So in our empirical evaluation, we try to answer 3 research questions. So first, we try to see the effectiveness of Divergate's main feature at finding different inducing inputs. Second question, we try to see how Divergate can perform on different scenarios and different settings. And finally, we try to compare Divergate with state-of-the-art approach. In this presentation, we'll try to quickly answer the first and the third research question. So for the effectiveness of Divergate, the effectiveness of Divergate's components, so we have 2 main components in Divergate. The first is the domain-specific metamorphic relation, and to see how much is effective, we simply, in the first experiment, we simply try to get our metamorphic relation, and we try to generate these metamorphic relation in a random manner using just randomness. And by applying a simple random sampler, we can generate 22 times more different music inputs than the original test data, which prove our first assumption that traditional techniques and the test data cannot cover the real impact of quantization. We need an advanced technique to see how much we lose when we apply quantization. For the second experiment, we tried to see now the improvement that we can get if we try to apply population-based metaheuristic. And we see like population-based metaheuristics can improve the generation process, and it outperforms a random sampler and can generate up to 24% of diversion rate. Now, in the third research question, we try to compare our method with the state-of-the-art technique, which is DiffChaser. It's a search-based framework that uses genetic algorithm to perform targeted and targeted attack to expose behavioral divergences among DNA inversion. And results shows that Divergate can outperform DiffChaser with a success rate that is 4 times higher and with a comparable execution time. So to conclude, in this presentation, we try to answer the quantization assessment of deep neural network by proposing a dedicated approach, which is Divergate. So Divergate is a search-based software testing framework that uses metamorphic relation and population-based metaheuristic to generate different inducing inputs and to try to assess the real impact of quantization methods. And we prove that Divergate can generate meaningful test inputs and can outperform the state-of-the-art DiffChaser. With that, thank you for your attention, and if there are any questions. Yes.
Thank you very much, Ahmed. We have a couple of questions. I'll let Ahmed go ahead.
Yeah, hi Ahmed. First of all, thank you for the interesting presentation and nice approach. So I just have a question. So back to your slide 13, where you show the flow chart or the components of Divergate, right? So my question here, you mentioned at the end there is a stopping criteria. So what is the stopping criteria here?
Yeah, so we have like several stopping criteria. First of all, the classical stopping criteria is the number of iteration. If you try to generate, like, you need to specify, like, if you need to generate 10 population or 100 population and so on. So this is the first stopping criteria, but we have add other criteria, intelligent criteria, like if the generations stagnate in some point, if like the population doesn't improve, like in 3 or 4 successive generation, we stop the generation to not waste time.
Okay, thank you.
And Khaled, if you can go next.
Yes. Okay, so first of all, thank you so much for the great talk and congratulations on that paper, of course. So I have like 2 questions maybe. First of all, when you metamorph the pictures, right, or the images, how are you sure that they are like they keep the original class, right? How can you like verify if they keep the original class?
Yeah, great question. I have some slide for that, if you don't mind.
Yeah, sure, no worries.
Yeah. So we try to be so conservative in that manner, because like you said, if we try to metamorph too much the distortion, we lose the semantic of the image. So yes. For that, first of all, we try to work with the domain expert to have the range of each distortion, like what are the realistic range of any distortion. So it's the first validation, like any generation needs to be in the specific range, and we use like a metric like PSNR, like to measure the noise injection, how much we inject noise, and we need to be too conservative for that. And also, this is for a single application of transformation, like if we try to apply rotation or like we inject some noise. But in our approach, we try to combine multiple transformations. So we need also to have a second validation when we try to always when we generate, try to have a PSNR less than a specific threshold.
Excellent. So if someone was to use Diverget, they will need to kind of understand what's the limits of metamorphic relations they can apply on their data set, right?
True.
I'm guessing. Yeah. Okay. Excellent.
Yeah,
excellent.
The input, like you want to try to Diverget on another or any type of situation, you need to come up with a transformation and their specific range. Like in your expertise, how are the range? You only need to specify the range and the transformation, and Diverget do the rest.
Excellent. And so like in general, I guess from your knowledge, how much do like the original model and the quantized model differ, like in normal use cases, right? So like if the data set is not distorted, if it's just like the same data set, how much difference do you usually see in performance?
So in our case, when we try to see the quantization effect, like we use test data only, it's almost the same. Like if the model is 90%, the quantized model is like 89 or maybe 90. But if we try to have an advanced technique like that, we can reduce precision like to 60 or even less.
Wow. Okay. And I guess one last, sure, surprising question would be, have you seen an instance where the quantized model like labeled the image correctly, but the original model did not?
True. Yeah.
There is.
There is. You can see, like in our metamorphic relation, we try to get all the differences. Like it's a comparison. Anyone who fails is considered as a failure for us. So we see like there is sometimes the quantized is better in some cases. We explain that like if you reduce the precision, maybe in the reduction, there's some loss that goes the other way and make the prediction correct.
Okay. Very cool. Thank you so much. Excellent presentation again.
Thank you.
Thank you, Khaled. Do we have any more questions from the audience before we pass things over to our next speaker, Jasmine?
I guess there is a question.
Yeah. Hello. Yeah, I raised my hand.
Yes.
Okay. Yes, I see you. Go ahead, Samuel.
Yeah. Mine is just a straightforward question. So, sometimes when we're using a set-based algorithm, there's some sort of randomness, like there's some sort of randomness. Like, I don't know if you touch on how they dealt with the randomness in using set-based algorithms, or if I missed it.
Yeah, in the evaluation, you say, May?
Yeah.
Yeah, so in the evaluation, we tried to repeat the experience multiple times, and we like do some statistical analysis, like the effect size and like we have statistical analysis to prove that the generation and the results are based on real differences, like are not that randomness.
Oh, okay. Okay.
Thank you, Samuel. Last chance for any questions for Ahmed for his great presentation. Very interesting.
Thank you.
No? Okay. If any questions come to mind between now and the end of our session, please just keep it in your mind. We might have some extra time at the end where we can save those questions. So thank you again, Ahmed, for your very interesting presentation. And I'd now like to turn things over to Jasmine so she can start her talk. You ready, Jasmine?
Hello, can everyone hear me and see my presentation?
Yes.
Yes. Okay, perfect. Okay, hello everyone. My name is Jasmine. I'm from Concordia University, as Lori previously mentioned about me. Today I'll be talking about my work on dependency management, specifically on the NPM ecosystem. So it's an empirical study on production dependencies in NPM. I presented this at ASC last month, and I had the pleasure to work with Dr. Mujahid, which is now senior machine learning engineer at Mozilla, and Dr. Costa, which is now at UQAM, and of course the support of my supervisor, Dr. Shihab. Okay, let's get into it. Hello. Okay, so I want to start by saying that we almost never write software from scratch, right? We reuse code in the form of open source packages. And if you do write code from scratch, I will not believe you. So code reuse is so widely spread that there's 80% of the application's code that actually comes from dependencies. And in fact, there's also the majority of modern softwares today that do rely on dependencies. The popularity of this is due to the fact that it allows us to write code faster, and this for a lower costs. As a testament to the popularity of open source packages, there are many platforms to host those packages. One that is very relevant to our study in this case is NPM, which is the package manager for JavaScript. And it's currently hosting over 2 million packages, maybe even as we speak right now, 3 million. And it's used by over 11 million developers. So although reusing code and open source packages has many, many benefits, it's not all pink, and it does have a darker side. So what I'm showing you here is the dependency graph for one package only. And I'm showing you this because when you install this one package, you're actually becoming dependent on 170 other packages, and it creates over 350 dependencies in your project. So code reuse can make our projects depend on a very large number of packages, and this in turn can expose our softwares to security vulnerabilities. And in fact, there's nearly 40% of NPM packages that do rely on some kind of vulnerable code. The problem here is that we need to maintain our softwares by updating our dependencies to make sure that they are not affected by those vulnerabilities. But when we look at this graph, how do we know which dependency is really important to our software? Are they all equally important? Which dependencies are critical to our software projects? So why do we care about critical dependencies? Why should we be bothered by this? Well, I'm going to give you a few examples. The first one is with Equifax, which occurred, it's an incident that occurred in 2017. What happened was that there was a security breach in one of their packages, namely Apache Struts, and it led to the data breach of millions of American citizens, and it ended up costing the company almost $2 $2 billion in security upgrades and lawsuits. And more recently, if you are in Canada, you may remember this. It happened in July 2022 with Rogers, which is one of the biggest communications service provider in the country. And there was a faulty update in one of their critical components. Unfortunately, we don't have more details about this yet, but I'm sure we will soon. And it ended up affecting 25% of the Canadian population. It brought down all the banking services. I don't know if you remember, but we could not make purchases at the store. We could not take out cash. It was really widespread, and even worse, we could not even make 911 phone calls. So my point here is that it's so important to know about which components of our softwares are critical, because one simple faulty update can take down an entire system, and beyond having major financial consequences, it can even affect our daily lives. So which dependencies are most critical within our software projects? So we can look at this in the perspective of software development process. So like I said, when we write some code, when we want to build an application, we start with writing some code. And like I said, we never write this code from scratch, right? So our code depends on some packages. And those dependencies are what we call development dependencies. Those are dependencies that we use at development only locally, for example, when we want to write some unit tests. And then we want to validate our application. We want to see, does it meet the requirements and the specifications? So we run it. And those dependencies that are needed by our app to function are what we call the runtime dependencies. And then finally, we deploy our app to the rest of the world for others to use. And the dependencies that are deployed with our software are what we call production dependencies. So the further we are in this process, the more critical the dependencies are, because this is where our software is used by real people. So the dependencies that are deployed to production are the most critical to our software systems. So how do we identify those dependencies that are used in production? To illustrate this, I just created a very simple example. So we have our app here. And like I said, our app depends on some packages. And those packages offer us some kind of functions. So we have files, and those files have some functions. And as our application uses some of those functions. But in all of this, we are not using everything, right? We may only use a small part of it. So for example, one function that is found in one file from one package. So how do we get rid of the dependencies that we are not using in our code? So to do this, we used build tools like Webpack and Rollup. And the special thing about those build tools is that they provide a mechanism that we call tree shaking. Tree shaking is basically a dead code elimination process, and it relies on static code analysis. So basically, it scans your project's code base, and for every installed dependency that you have, it looks up, is this dependency used in the code? And if it's not used in the code, it is just simply removed. And what we are left with are just the dependencies that are used in our code and are deployed with our software to production. So because dependencies are such big parts of software projects and they're so important, we wanted to better understand how they're used in practice and how they impact the security of software. So first, we wanted to assess how often dependencies are actually deployed to production. And then because the dependencies in production are the most critical, we want to establish more of a practical understanding of the context in which they're used. So we do that by identifying their types. And then lastly, because it's when a compromised dependency is released to production that it ends up being the biggest threat to our application, we wanted to investigate how often the security alerts are actually emitted for dependencies in production. So here, I'm just going to give you a small overview of our approach. And then for each research question, I'll go in more details of how I answered each question. So for our data, we started our data collection from over 11,000 JavaScript projects. And then because we needed tree shaking and this kind of mechanism, we wanted to identify projects that used either Webpack or Rollup. And this ended up only being 155 projects out of the total 11,000. And then what we did is we cloned each of those projects, we installed all of their dependencies, and then to be able to look at the production dependencies, we had to successfully build each project. And we were able to successfully build 100 projects. So we ended up with a data set of a total of 100 JavaScript projects and over 200,000 dependencies installed in those projects. So for the first research question, how many installed dependencies are in production? So to quantify this, we first, like I said, needed to build all of the projects. We really tried to automate this step, but it ended up not being possible because we noticed that most of the projects had different build configurations. So we had to manually inspect the build configuration of each project to obtain the correct build command. And then after this, in the next step, we use this build command to manually build each of the project. And this step was really important because this is where the source maps are generated. So source maps are super important for our research because, first of all, they're part of the build output, and they contain everything that is deployed to production with a software. So for example, it contains the source code, the static assets, and most importantly, the dependencies that will be in production. And this, I just want to say here that this step is also where tree shaking happens, that is at build time. So it removes all the unused dependencies. So it allows us to make sure that the dependencies we find in the source maps are actually used in the code. Finally, the last step was to parse those source maps to extract the dependencies that are used in production. So for the results of this research question, we collected over 53,000 installed dependencies, and out of which only 497 were used in production. So this means that there is less than 1% of the dependencies that are actually critical to the studied projects in this context. So now that we have identified those dependencies in production, let's look at their types. So by the types, we want to know are those dependencies that are deployed to production, are they development dependencies or are they runtime dependencies? How are they used? So to do this, we first use the npm ls command. So it's basically short for npm list. And what this does is that it generates the project dependency tree. So the project dependency tree is just a way to represent all of the installed dependencies and the dependencies of the dependencies within the project. And then we wrote a dependency tree parser to parse this dependency tree, and this allowed us to obtain the versions of all of the installed dependencies so that we could recursively identify each of the type of each dependency based on its configuration within the project. So we ended up obtaining a data set of installed dependencies that we grouped by name and version along with their types. And then to identify the types of production with dependencies, we just cross-reference our data set of production dependencies with the dependency, the data set of installed dependencies based on the version, and we obtained the types of production dependencies. So for the results of this research question, we expected that production dependencies would be all runtime dependencies because they are typically required for the software to function, right? But surprisingly, we found 139 development dependencies were actually deployed to production. So this result here implies that the configuration of a dependency does not necessarily indicate how it ends up being used. So in this case, we have 139 dependencies that are configured as development dependency, but they're actually deployed to production. This is potentially dangerous because we typically assume that development dependencies don't necessarily impact our software when it's deployed. So we may not prioritize them in maintenance tasks, and we may even just not care about them and just ignore them when we are updating our dependencies, because we don't typically think of them as being critical to the functioning of our software. So how does it happen to have dependencies in production? It's quite a surprising result. So what we did is we looked at how the dependencies within the projects were configured, and we identified three separate ways. So what I'm showing you here is the package.json of a dummy project that I've created. So the package.json is where dependencies are configured in JavaScript projects. And like I said, we identified three ways of those dependencies to be configured. So the first one is the conventional way. So that is to separate our dependencies in runtime and development dependencies. So runtime dependencies are declared in the dependency section of the package.json, and development dependencies in dev dependencies. Then there is another way, that is to declare all of our dependencies as runtime dependencies. So everything is in the dependency section of the package.json. And then finally, there is the last way is to declare everything as a development dependency. And we actually found that there were 10 projects in the study data set that were actually using this type of configuration. Why does it work that we put everything in whatever configuration in our software application still works? In this case, it's because tree shaking relies on static code analysis to resolve our dependency and not the dependency configuration. So it doesn't matter really where we put our dependencies within that configuration file, because it relies on the code instead. So it relies on the usage of the dependency, not the configuration. So for the last research question, we want to see the impact this has on security. So how often NPM security alerts are emitted for dependencies in production. So to answer this research question, we use the npm audit command, which is basically the built-in security tool for NPM. And this allowed us to collect all the project security alerts, and then we had to parse those alerts, and this allowed us to extract the alert severity and the vulnerable dependencies. So by vulnerable dependencies, I mean dependencies that are affected by this security alert. And then similarly to the last research question, we cross-referenced our production dependencies with vulnerable dependencies to see which alerts were emitted for production dependencies. So we collected a total of 608 security alerts, and amongst them, there were 268 that were of high severity and 45 that were of critical severity. But we found that none of those alerts were emitted for dependencies that are actually deployed to production. So what does it mean? It means that NPM is telling us your software is vulnerable, you have critical severity alerts, you need to act quickly, but in reality, those vulnerabilities have no way of impacting our software because they do not pertain to dependencies that are deployed to production. But this doesn't mean that we shouldn't care about those security alerts. It means that we are simply not well equipped to know which alerts to care about. So here we found that all of the critical severity alerts were actually emitted for development dependencies. And instinctively, we would not care about them because, like I said, we don't expect those development dependencies to affect our software in production. In fact, we could even ask NPM to ignore them for us, because tools like NPM audit or other security tools, they allow us to filter out alerts for development dependencies because they are supposedly not released to production. But we saw in RQ2 that those development dependencies can in fact be deployed to production. So it's dangerous to completely ignore the security maintenance of those development dependencies because they have a risk of being exploited in a production environment, even if we don't expect them to. So the problem is that we receive so many alerts, but we have no easy way of knowing which ones are actually relevant to our projects. And the tools like NPM audit or even Dependabot, if I can say, they make no distinction whether the security alerts are emitted for dependencies in production or not. And they also make no distinction between the usage of a dependency in the code or its configuration. So you can even emit misleading alerts. So it's difficult for us to filter out relevant security alerts to our softwares, and it can be dangerous. So for the main takeaway of this paper, I just want to start by saying that as developers, we spend a lot of time maintaining dependencies by updating them. And Updating dependencies is not as simple as just bumping to a new version. We need to consider what parts of a software are affected, and we have to deal with compatibility. So because of this, it's really important to prioritize dependencies that are critical to our software when we do maintenance tasks, because we don't want to waste our time on dependencies that don't affect our software in production. The problem is that we have no easy way of identifying such dependencies, and it's difficult to prioritize our maintenance efforts. And next, we saw that security tools make no difference between dependencies in production or not, and they rely on configuration instead. The thing is that we receive a large number of alerts. We struggle to know which ones are actually affecting our software in production, and it becomes overwhelming. We stop caring about those alerts, and we even lose trust in the tools, right? We've all seen the infamous, you have 100 vulnerabilities, and we just went, meh, next, right? We don't care anymore. The more we see, the less we care. But this may lead us to miss potentially real critical vulnerabilities, because it's in a sea of false positives, basically, and none of them are actually relevant to our software. Sometimes, like I said, those alerts are even misleading because they're emitted for dependencies configured as development, but they're actually released to production, and there would be no way that we would know. So it's really important that we are mindful about our dependency configuration. Even if the tools rely on static code analysis, we should be careful of how we configure our dependencies so that we know for the future. I think that's it for my talk. And here I just wanted to show a few pictures of ASE because it was a super nice experience. It was my first conference in person, and it was on the kind of Netflix university, American university. The campus was beautiful, and it was a great experience, and I'm super thankful that I got to go. So yeah, thank you everyone for listening, and thank you for my co-authors for supporting me, and to my supervisor as well.
Thank you, Jasmine. Great presentation. Does anyone have any questions for Jasmine? Ahmed, go ahead.
Yeah, thank you, Jasmine, for the great talk and nice slides. I just wondering, so part of your study, did you try to analyze the types of vulnerabilities?
Yes, we did analyze the type of vulnerabilities, and we found that the most, we found that the most common type was a DDoS attack. It was almost all of them were of this type, especially the critical vulnerabilities type. But none of them had a way to impact the software in production because they were always for dependencies that were never shipped to production.
Okay, I see. Thank you.
I think I said the word dependencies way too many times in this presentation. It's a bit hard not to.
Any other questions for Jasmine? Not only questions, but comments or Khaled, please go ahead.
Okay, so thank you so much, Jasmine. Great presentation as always. And congrats on the paper as well. So one question I had in mind is, did you notice, like, so are there specific packages that are used in production more than others? Like, is there a disparity between specific packages and how they are used? I'm wondering about that, and if that's the case, what are some of the characteristics of those packages, right?
Yes, there are actually. So there are packages that inherently are just used in development. For example, packages to test your software. Obviously, you will never ship that to production because you don't need to. But packages like Webpack is kind of on the fence, right? So sometimes Webpack is released to production. Sometimes it's just a development dependencies. It depends how you use it. Sometimes Webpack is just used to build your software, but sometimes it's also used to optimize how your app will show up, let's say, on a browser. It's used for compatibility. So in this case, it will be shipped to production. But if you just use it to build or development tasks, it will be just in development. There are
Mhm.
some that are just used at runtime, so in production all the time. I'm thinking React, for example. React
Yes.
is almost always in production if it's used, because it's like literally the whole app is built on React when you use
Mhm.
this. So yes, it depends on the functionalities you're using, but inherently some packages are always shipped to production and some are never shipped to production.
Okay, and so thank you for first of all. And so I'm thinking based off that discussion, do you think there's like some kind of community effort that can be put forward so that, you know, those packages that are most used in production should be prioritized when, you know, like issues are present or some vulnerabilities are present? Is there like, you know, do you have any ideas about what could be done there, or do you think this is an effort that could be put forward?
I think they already are, because when you are using React, you're kind of already aware that it's a big chunk of your app, and I think
Mhm.
you know you already know, so you will put more maintenance efforts. The problem is more where it's not a direct dependency and it's a transitive dependency, for example, that you're not aware of, and you get all those
Yeah.
security alerts for. So
Yes.
it's because transitive dependencies are even shipped to production, right? It's not just direct dependencies. So the problem is not with those big chunks of dependencies that you use and you're aware of, it's the ones that we are not aware of. So so for example, if you look at your package JSON, when you look at, does it work? Yeah, so when you look at your package JSON, those are all direct dependencies. Typically,
Yes.
you should know about them, so you know you should update them. Even if some of them may not be in production, you know. The problem is for those that are not there and that you don't know, basically.
Yes.
So I think the effort is already on those dependencies, but not necessarily on the ones that you don't see.
I see.
And yeah, I think the community effort should really be put on improving tools to give us more information on those dependencies that we don't see. And even those dependencies, I may have React script here. Maybe I'm not even using it in my code. I don't know that.
Yeah.
Right.
Yeah.
So I think this is where the effort should be put, giving us more details.
Super cool. Thank you so much.
And thank you, Khaled, for helping me for those slides. Khaled gave me very good feedback on them. So props to him.
Okay, I see that Haya has a question. Haya, please go ahead.
Yeah, thank you, Jasmine, for your presentation, and also for Ahmed. Jasmine, I wonder if we change the bundle tool or build tool, does the result hold? I mean, the production dependencies are the same. Do you experiment this part if we change the?
Yeah, I think it would be the same. We only picked Webpack and Rollup because, you know, they're the most popular right now and they were used in a lot of projects compared to others. But the mechanism is the same, right? So what's special about those tools, specific to these types of projects, because we focused on web projects mostly, is tree shaking. You see, Webpack is built on Rollup. So Rollup is like the ancestor of Webpack, so they do work in the same way. They offer the same I guess the same features. It's just that some of them are more lightweight. Rollup offers more features, Webpack a bit less. So they are inherently the same. It's just different features that they offer. So yeah, they do produce the same kind of bundle if they use tree shaking, of course.
Okay,
I think
thank you.
It's a matter of what you're looking for when you're using them.
Yeah, thank you so much.
Thank you, Haya. Any other questions from any of the participants? Either
I have one, but I couldn't raise my hand in the tool.
Okay, please go ahead.
I don't know, Jasmine, but if NPM provides like the audit for a development package, why don't we use the same idea but in production?
So what you mean by it uses for development package, that you mean that we can filter out alerts for development packages?
Like the NPM audit command.
Yeah,
why not use it in
so
production too?
because the way NPM does it is wrong. It's not good, because I just tried to find my slide here. I'll just show you. So NPM relies on this file to say this dependency is in development or it's a runtime dependency. But it's not because your dependency here is configured as development dependency that it will not be used in your code and shipped to production, right? So it's not good to only rely on the configuration. And this is what NPM does. When it says, when I say tell NPM, look, filter out all the alerts for development dependencies, it will look at this file and say, oh, this is development dependency, we're not showing any alerts. It doesn't look if the dependency is actually used in the code. So this is why we can't use this. In my opinion, I think it should rely on more a static code analysis way to filter out those alerts. Hello?
Okay, yeah.
Yeah. Okay,
okay,
sorry, I
thank
thought
you.
my, yeah.
Yeah, thank you. Thank you for the.
Okay, I'm just being mindful of the time. We have about 2 minutes left.
We're right on time.
Yeah, we're right on time. I think it went really well today. I'd like to thank everybody for joining us. Our next Trainee Talks will be on December 13th. So I really hope that you'll be with us again to hear 2 more of our Create SE for AI trainees delivering talks on their current research. I think today's first session went really well, and I think everybody learned something. I know I did for sure. And the recording will be available on our YouTube channel. It'll also be available on our seforai.org program website if you'd like to listen to it again. So with that, I'd like to thank Ahmed and Jasmine for being our speakers today. And thank you to everyone who joined, and have a great rest of the day and weekend. Thanks, everybody.
Thank you, Lori.
Thank you.
Thank you, Lori.
Thank you. Bye-bye.
Thank you, Jasmine and Ahmed as well.